Hi, this is the part 3 of the tutorial series on scalability and solving some of the scalability problems using caching. In the part 1, we looked into what is a cache, how caching solves some of the performance related issues. In the part 2, we looked into two of the caching strategies. If you have not looked into part 1 and part 2 and directly coming to part 3, I would strongly recommend you to take a look into the part 1 and part 2, wherein which the fundamentals are clearly discussed. It is a mandate, it is, I strongly recommend, and it's not mandatory though. Refresh ahead. What is a refresh ahead cache pattern? A cache is refreshed asynchronously before the TTL, thereby ensuring no cache misses. Okay, why do we need to refresh a cache? TTL is the time where the cache gets expired. Just before the cache is getting expired, why do I need to refresh the data? Usually TTL expires the data. Um, so we should understand the clear use case of this in terms of financial markets, in terms of the gaming and sports. The data is refreshed on those keys which are accessed after the 50th percentile of the TTL, after the 50th percentage of the TTL. For example, if the TTL is configured to be 1 minute, assume if the data is accessed after 30 seconds before 59th second, just before the TTL comes, the data is refreshed. It means that the data is looked into recently by people, but we want to get the refreshed data from the data sync. Maybe there is an update which has happened. This ensures that underlying mutations are reflected just before the TTL happens or not at the time of TTL. This is an alternative approach to write through cache and it fits and overcomes some of the problems around atomic writes between cache as well as the database. Um, there are few systems, underlying systems, which supports refresh ahead cache fundamentally. Um, we will look into those systems a little later. What as we review some of the caching engines like Redis, Hazelcached, Memcached, which engines support what type of caching strategies, we'll look into it later. Then, when is a cache hit? When the data is present in the cache. When is a cache miss? When the TTL expires it. It means so we just said that we are going to expire before the expiry we will refresh the cache. It is not applicable to all. For example, if the TTL is set as 1 minute and if the data is not accessed throughout the 1 minute, then we will not refresh the cache. If the data is refreshed, the data is refreshed only when it is accessed at least once after the 50 percentage of the time or whatever is the configured percentage of the time, then only the data is getting refreshed. This ensures or reduces the stale data being served to the underlying access layer without much effort on the underlying data sync layer. There is no need for us to load the data manually. This could be a strategy followed by the caching engine itself. Underlying the caching engines, modern day caching engine, can be configured to query from the database and provide this is the access pattern. They automatically refresh this data. We don't need to be doing extra effort like application layer need not worry or the data layer need not worry. We don't need to be writing or relying on CDC also to do all these patterns. The underlying caching layer provides these kind of querying mechanisms as well. We can take advantage of that to ensure the stale data, that the cache becomes eventually consistent as well on the mutated data. So the data is loaded from the cache if present when TTL is expired for infrequently accessed data. Okay. The data is read through the DB and it put back to the caches. For example, infrequently accessed item, the DTL expires it. When what happens in terms of read, we have to read from the database and put it to the cache and then serve it back. This pattern we have already seen it, but for frequently accessed items and nearing TTL, this pattern helps. This what is the drawback? I'm I'm thinking that could be a cache stampede. Okay. Assume that we are going to the percentage is configured as 50, right? 50%. After 50 percentage of the time, whatever data which is being accessed after 50% of the TTL, we'll go and refresh the cache back. So assume that 100,000 records are accessed and there are 1 million records in the cache, which means 10% of the data. The underlying data gets queried immediately unless the caching engine handles that with a jitter, right? They send the caching engine sends the queries for these keys asynchronously, not at a one point of time, but in a staggered manner. It creates a spike in the database also. We need to be carefully evaluating this when we are choosing this approach from a particular caching engine. I would strongly recommend the architects to go and do this test scenario. Usually, these kind of tests is the responsibility of the senior engineers and the architects to think through it. We may get easily attracted towards some of the advantages, but what will happen in the production is suddenly stampede happens. Oh, we have used this pattern in the wrong manner, and the underlying problem will become not solved at all. So we need to be doing this test. I have not used this pattern in production, double quotes, but if I am going to use this pattern in production, I will run this test, then only I'll put this pattern in my production system. Okay, let's look into the next. What is write begin? This is another caching strategy. Writes are performed on the cache store only, and the response is sent back to the user. As I said, initially told writes need not be scaled via this, but this pattern says that I want to use cache. I want to write to the cache first, and I ensure that will be sent back to the underlying storage layer using a CDC or whatever it is. But I am okay with that. I can be eventually consistent, and the data is refreshed to the underlying system asynchronously. This approach does not wait for the data to be acknowledged by the DB. Okay, so as soon as the data is returned to the cache, the response is sent back. We need not wait. The data, we need not do an atomic rate, which we discussed in the previous lecture, that the data has to be returned to two systems, database and cache atomic rate. No, this atomic rate is only for cache, it is not to the DB. Write behind approach is used when the underlying system writes to the DB and that could the underlying DB is low. For example, if the write has to be scaled faster, but the underlying write cannot be faster. So this is time we will use this approach. And a sudden spike cannot be handled. This approach has to be working in tandem with read through cache. We looked into write through cache. What is read through cache? Read through cache is read from the cache first. Don't look into the database at all. If an item is present in the cache, return from the cache. So your first read should be on the cache next to the DB. So it means infrequently TTL items can be looked back into the. I'm not considering the TTL scenario. Assume that whenever I miss that part, you have to fill in that gap. The item is not present, it is TTL'd. So I'll look into it. Read through is read first cache. Write through is that way, the opposite of the way. So let's look into uh, this has to be in tandem with it. As we talked about CDC, we can use CDC mechanism of the caches if the engine offers that capability. Whenever the data is written to the cache, the cache engine underlying should, or some of the caching engines already offer. So we use the CDC approach to write back to the database so that the database becomes eventually consistent and ensure that this approach will work only for two scenarios. Data can be eventually consistent. Point one. Second, all the writes are primarily to the cache, and the underlying caching store or the intermediate layer has to be highly distributed. There is no single point of failure. An architect has to think through this problem statement. If the cache is available only in two availability zones and it is available in only one region, and if the region goes down, this approach will be catastrophic. Ensure that the caches are multi-region and a CDC kind of approach is used because the cache engine emits and guaranteed writes our writes are guaranteed to the database. We have to ensure all three things for using this pattern. So additional as we look into it, when the cache will be hit, when the data is present in the cache, when the TTL expired, it is not available. I don't want to repeat on this. We will look into the detail in the upcoming videos. The data is written to the cache first. This we need to. So since all the reads are looked into the cache, cache will be at load all the time. Yeah, but it is designed to scale because it's more of a lookup pattern. So we need not. And the writes are also to the cache, and many people will be looking to, for example, what you can do. Get me all the keys which are written in last 1 minute. We can use this kind of pattern to write it back to the database if the underlying engine doesn't offer CDC and I cannot guaranteedly perform the operation on a CDC. We can query all the keys I have found it during a certain point of time, or which is written in certain duration, and then write it through database as well. But this also adds load to the cache. So we are constantly seeking from the cache. Oh, is there anything that got changed? Is there anything that got changed? This adds load to the cache engine as well, which we need to consider because all the reads are directed to cache as well, and we are also using reads to ensure the database is in sync also. 2x, not 1x, 2x. As part of capacity planning, people should consider that. This is where people will falter. Okay, so an architect should be clearly thinking through the nuances of a caching strategy while they do it. CDC would be a savior here, but the correctness and the guaranteeness of the data or capturing the CDC is on the onus of the system which is processing it. CDC doesn't guarantee that the data is so, but we could use it. There are chances that if the data is being fetched from the DB, there are other systems which are okay to read the data in a slower manner. They could see some stale data that is applicable, that is given. That is the time we use. We have looked into several caching strategies. We will do a little summary, right? Uh, right begin, right begin writes to the cache first. All reads are from the cache, and the DB asynchronously synchronizes the data. This is the write behind pattern, which is explained in the video. Read through and write through. This has to work in tandem with each other. Data is written and read from the cache first. It is responsibility of the writer to write back to the DB. As I said, the atomicity or ensuring the guaranteed data to the DB, it is the responsibility of the application that we need to be. Cache aside pattern. Data is read from the DB. If the cache is not hit, the cache is loaded from the DB and the data is written to the DB and the cache gets invalidated. This is the first part that we looked into it. Cache gets invalidated. Last, refresh ahead. The data is refreshed before the TTL, eventually ensuring the cache data is refreshed. The frequently accessed cached data is refreshed or kept refreshed all the time. That is the advantage of this pattern without putting much application. We don't need to be remembering what is read behind, what is read through, write through cache aside. That's not expected. But we should be very careful in evaluating what approach we take and what are the pitfalls. How do we overcome those pitfalls? What are the steps that we need to ensure while we choose the right caching strategy and how it affects our production? That is the intent of the video. So I hope I would have added some benefit to whatever the knowledge that you already have. Mm, I said thank you, and this is Balasubramanian. As till we meet next time. Bye.